All right, in this video, we are given this trigonometric word problem. Over here, we basically have the depth of the water is given by this equation over here. It's in meters, where t is just the time since midnight in hours. And we have a ship that needs a depth of at least 13 meters dock safely. So the depth has to be 13 meters or above. And we need to find the times between midnight and noon that the ship can dock safely. So the first thing we want to do is we just want to get a couple of key features and we want to sketch a graph of this. In these types of questions, it's generally a very good idea to sketch the situation out. So looking at this equation, I can tell that the amplitude is just 2.5. The k value is 0.164 pi, which means that my period is 2 pi divided by 0.164 pi. And I'll do this in my calculator. And I get 12.2. So approximately 12 hours. This is probably just rounded a bit off. Technically, I'm not sure why, but it's just done like that. So 12.2 hours, approximately 12 hours, basically from midnight till noon. So we know that we're just going to be talking about one period of this wave over here. So we just have to draw one period of this graph, and that will cover from midnight till noon. Then we know that the equation of axis over here is y equals 13.6. That's the number at the end. And we have a phase shift of 1.5 to the right. So now we can start doing our sketch based on this information. I know that it's a real life situation, which means I only need the positive values. I have my depth over here, and then I have my time on the x-axis. I always start with my equation of axis, which is y equals to 13.6. Then I like to find my maximum and my minimum point over here. In this case, I'm going to add and subtract my amplitude, which is 2.5. 13.6 plus 2.5 is 16.1. My max is 16.1. And 13.6 minus 2.5 is just 11.1. So my min is 11.1. This scale doesn't have to be super accurate. It's just a sketch to help solve the problem. Now I know that there's a phase shift of 1.5 to the right, and this is a positive sine equation. So positive sine equation would normally start on my axis right over there, but now it's going to start over here with a shift of 1.5 hours to the right. Once I have my starting point, I can find all my other key points. I can just find my end point first. I'll just draw one cycle of this out. That's what my first cycle looks like. Find this ending point over here. I'm just going to do 1.5 plus the entire period, which is 12.2. So 1.5 plus 12.2 is just 13.7. So that's one period over there. That covers more than midnight to noon, because midnight is over here at 0, which means the noon will be somewhere over here, which is at approximately 12. So the next thing I want to do is I want to solve my equation. Basically, I want to find where my depth has to be at least 13 meters. Now this over here, I have to extend it a bit. You don't know exactly how much, where it's going to hit, but some of the hit over here on the y-axis. We don't know exactly where. That's not super important. Just to note that it's not going to be a minimum. It's going to hit the y-axis somewhere over here. So now if I want a depth of at least 13 meters, 13 is basically somewhere in between these 2 points, probably slightly closer to this than to this. I'm just going to draw it over here. This is 13 meters basically. I need to find when the depth is above 13 meters. That's when the ship can dock safely. So above 13 meters, I know is going to be from this point till this point over here. I don't have to worry about this little bit because I know that's going to be well after 12. Okay, but when I do my calculation, I can prove that as well. But most likely my answer is just going to be from here to over here. So I need to find these 2 points. And when I find these 2 points, that's going to be my solution to this question. In order to find these 2 points over here now, I have to use the equation again. I have to replace the depth with 13, and I have to solve for the time. So to solve this equation, the first thing I'll do is I'll subtract this on the other side. I'll get negative 0.6 equals 2.5 sine 0.164 pi t minus 1.5. Next, I'll divide both sides by 2.5. Get negative 0.24 equals to sine 0.164 pi t minus 1.5. Next, I'm going to do the sine inverse of the other side. Make sure your calculator is in radian mode. And if I do the sine inverse of negative 0.24, I also get negative 0.24. It's a bit of a coincidence, but these things do sometimes happen. And 164 pi t minus 1.5. Oh, actually, I made a tiny mistake there. Before doing the sine inverse, remember to always do the cast rule. Oh, actually, I don't really need to do it. I could do it, but I'm wondering whether I should use cast rule. Nah, I'm not going to use cast rule. Actually, I'll just continue. Could use cast rule over here to find your 2 points as well, but I'll just do it like this. Not really a huge difference. So next, I'll divide both sides by 0.164 pi. Then negative 0.47 equals t minus 1.5. And last, I'll add the 1.5 on the other side. And I get 1.03 equals to t. So if I look over here, I have three different points, 1, 2, and then this third one over here. I have three different points that could be my solution to 13 meters, but 1.03 is obviously this first one over here. So that point has an x value of 1.03. I know this point is one entire period later, so I can add 12.2 to this answer, and I can get this as 13.23. Now we know that our answer should be between midnight and noon. And if our answer has got to be between midnight and noon, that means that anything above 12 is invalid, which means all of this here is technically invalid. I don't need it at all because noon ends somewhere around here. This is when noon is. And this whole part is below, which, like I said, means my answer is between this point and this point here. So I've already found this point is 1.03. I just need to find this point over here. Okay, in order to find this point over here, what I can do is I can start by finding this axis point over here first, which is the midpoint of this axis and this axis point. So the midpoint of these two is going to be 13.7 plus 1.5 divided by 2, which is 7.6. I just did the midpoint of my other two axis points and I got this axis point. Now this tiny gap over here is the exact same as this tiny gap over here. So to find this gap, I'm going to do 1.5 minus 1.03, which is 0.47, which means this gap over here is exactly the same. It's also 0.47 as well, which means that this x value is just 7.6 plus 0.47, which is 8.07. So this point over here is 8.07. This means that the ship can safely dock between 1.03 hours after midnight to 8.07 hours after midnight. If you made it to the end of this video and you found this content useful, please hit the like and subscribe button as it really helps this channel. I'm trying to get to 1,000 subscribers as I want to get my channel monetized. I'm pretty close right now. And right now, this is video number 9 of 513 without making a single dollar. So help me get monetized and make some money before I maybe reach 550 videos. Thank you for watching and have a nice day.